Hi, I'm Mr. Franklin, and in this video, I'm going to do a quick explanation of Newton's first law. We're going to actually look at a couple of situations. First, floating in space, then on the grass, and then we're going to look at a couple of others. This video will just be on an object floating in space, so let's get into it. So we have a soccer ball with some mass floating in space. We're representing the forces acting on this soccer ball by drawing a free body diagram. You can check out that video for an explanation of those. But there are no forces acting on it, so there are no arrows drawn. So that means the total force, the net force, is equal to 0. By Newton's second law, if there is a force causes an acceleration, and acceleration is a change in motion. So Newton's first law, an object at rest stays at rest. So it's at rest. Its motion is not changing, and its velocity is 0. Speed in reference to a reference point is 0 as well. So net force is 0, acceleration is 0, and the velocity is 0. Now I come along and I give the soccer ball a push, a kick, while I'm in space. I kick it in a straight line. So as long as the kick is applied, as long as my foot is in contact with the soccer ball, there is a push on the soccer ball. Now in reality, that push is done and over like that, but I do have a force going in that direction, so that's the direction I drew it. Even though the kick is on this side of the soccer ball, we draw the force from the center of the object towards the direction it goes, okay? That results in a positive force. If I have a positive force, I'm going to have a positive change in motion, which means acceleration. And that also means that my velocity will wind up increasing. It's going to be positive. It's also going to increase at an increasing rate as long as the force is applied. Now, once we are done with the kick, in that split second we're finished with the kick, we actually have this happening, where the ball is moving, there's no more forces acting on it, so the net force is 0. Acceleration is 0, so its motion is not changing anymore, but now it has a constant positive velocity. This will happen forever without stopping unless an outside force stops it. Now it could be it runs into the wall of the spacecraft. It could be another astronaut comes along and kicks it back, but there has to be a force to stop it. So let's say, for example, it hits the wall. It's going to get a push from the wall. So that push will be as long as the ball is in contact with it. So force net equals the push. The push is in the negative direction, so the force net will be negative, which means the change in motion will also be negative. And the velocity, this actually kind of depends on the actual value of this force, okay? But the velocity could be a couple of things. It could be positive, but it will decrease at an increasing rate, or it could wind up being negative with a decrease at an increasing rate, or it could be 0. So those are the 3 options that could happen. So depending on how strong this push is, the ball could actually wind up traveling the other direction, okay, which would be the negative velocity. Or it could be the ball is just slowed down. So if you've ever received a soccer kick and you can slow the ball down, but it's still going in the positive direction, okay? So, but with a negative force, just a short, abrupt force, it's going to be decreasing at an increasing rate, okay? Okay, so let's do a quick recap and put it in plain English. Floating in space, it's at rest, it's not going anywhere. There are 0 forces acting on the ball. Here, we push the ball, it's going to accelerate momentarily. It's going to accelerate, and it's going to have a positive velocity. Now that velocity will increase as long as there's a force applied, but with a kick or a push, that force is over in an instant. And so now we have no more force acting on the ball here, but nothing has stopped it from moving. So it's going at a constant velocity, and that velocity happens to be positive. So remember, positive, negative only means direction. This one, the velocity is not increasing or decreasing. It's staying constant. Over here, we have a force, so it's going to increase at an increasing rate. That's what's going to happen with a positive acceleration. Okay? And then over here, we're not sure what's going to happen, but we do know is it has a positive velocity, but it's going to have a negative acceleration, which means it's going to slow down, maybe stop, maybe change direction. Okay? So it's going to maybe stop, maybe slow down, maybe change directions. We don't know what that's going to be because we don't know how big the force actually is. So how does this make sense? Well, we don't know how big the force is. So you could kick it to someone and they could apply a force and stop the ball. They could catch it. They could, whatever, stop the ball. But they could just slow it down, okay? But I could also kick it back at you and change the direction of it. So let's not get too wrapped up around that. Just know that this will not change its forward motion until a force stops it, okay?